What's happening, dogs? Mr. Allen here with some solving of equations by factoring. In these four examples that we have right here, we're going to focus on factor by grouping. And one thing you're going to notice in common with all these is they have four terms. That is an indicator to use factor by grouping. We also have all four of these already equal to 0, but if they weren't, you need to get them equal to 0 before you try to solve by factoring because you're using the zero product property. All right, enough of that. Let's get after it. We got different scenarios for each one of these here, but they all start out the same. We're going to group the first two terms and the last two terms. I always make sure to include that sign there in my second group of parentheses. Now, this looks like multiplication right now. It is not, right? I just grouped them. Okay, there's really addition between them. But I'm going to take out my GCF of these first two terms right away. All right, so I got x squared can come out, and I'm left with x minus 4. Next one here, I can take out a negative 9, so minus 9, and I'm left with x minus 4 when I factor out that GCF. Cool, beautiful, wonderful. So now we have two different terms. They're actually two terms, but they're really odd looking for considering them as terms, right? But they are terms, no less. They're joined together with multiplication. X minus 4 and x minus 4, those are my GCFs of each of these two terms. So we can take out an x minus 4 from each, which leaves behind the x squared and the minus 9 equals 0. From here, parenthesis, from here we could really set them equal to 0 and solve for x. But because we're asked to solve by factoring, I'm just going to continue factoring this thing straight through until it can't be factored anymore. So we got x minus 4, and the x squared minus 9, that's a difference of two squares. So I've got x minus 3 and x plus 3. All that equals 0. Now I have three factors, 1, 2, 3, all equal to 0. I can set them equal to 0 and solve for x individually. So we have x minus 4 equals 0, x minus 3 equals 0, and x plus 3 equals 0. So remember, if I get any one of these three factors to equal 0, the entire equation equals 0, regardless of what the other two factors equal, right? So if I get x equals 4 here, if I were to plug 4 in, right, to all three of these, I'd have 0 times 1 times 7. That equals 0. I didn't even care what the other ones equaled, right? I got one of them be 0, it all equals 0. That's the zero product property. That's why we set it equal to 0 and solve for x. It's not just some magical thing, right? There is reason behind it. So for this one here, I got to add 3, so I get x equals positive 3. And over here, I'm going to subtract 3. I get x equals negative 3. Cool. There we go. First one done. Factor by grouping. It's one of my favorites, right? One of my favorites. I don't know. They're all my favorite. Factoring is my favorite. It's my favorite F word, factoring. All right. Let us continue here. When I look at this problem right off the bat, I see all four of these terms are divisible by 3. So I can actually just go ahead like this. Boom. Divide by 3. Divide by 3. I can do that because it's an equation. If this was an expression and I was just asked to factor, I'd have to take that 3 out as a GCF of the entire thing. All right, but because it's an equation, I can divide by 3 on both sides. And now I just have x cubed plus 4x squared plus 2x plus 8 equals 0. And now I can go ahead and group these. I'll do that in a pink marker here. So group the first two, group the last two, all right? And now once again, it's just like this one, we're going to look for some GCFs, okay? What do these have in common? It's going to be x squared. And I'm left with x plus 4 this time. Over here, I can take out a 2, a positive 2, and I've got x plus 4 equals 0. All right. So now we got our GCF here, and here is going to be x plus 4. They have that in common, so I take that out. If you're not recognizing that as a GCF, it's not the end of the world. That is mathematically what's happening there, but usually we just see like, okay, these two are the same. Boom, that's one of our factors. The leftovers, that's another factor. All right. So now I got this thing factored. Can I factor this any further? No. If it was a difference of two squares, like we had over here, then I could. But this one cannot be factored across the set of real numbers. All right, you can do it across a set of imaginary numbers, and it's a little odd. We'll get there another day. All right, so I'm going to take x plus 4, set it equal to 0. X squared plus 2, and I'll set that equal to 0. This one's easy to solve. I get x equals negative 4. This one will take a little bit more work. Work, like Rihanna. Okay. I'm going to subtract 2. I get x squared equals negative 2. Then I'm going to square root on both sides, right? So I will get, I'll put it right here, x equals plus or minus, right? We got to have the plus or minus when we're using square roots to solve, right? I got to account for both solutions there. If I was just simplifying a radical, it just is what it is. When I'm solving using square roots, I have to account for both the positive and negative possibilities there, okay? And then a negative inside the square root. an I needs to come out here, right? That's how I deal with a negative in the square root. And I cannot break down the square root of 2, so it just stays square root of 2. So a little bit of fuss there on that one, but not too bad overall. We've got 1, 2, 3 solutions there. It is a cubic equation here, so we should have 3 solutions according to our fundamental theorem of algebra. The degree matches the number of solutions. Sometimes those solutions are the same, right? We could have like x equals 3 and x equals 3. It still has 2 of those, but they're not unique, okay? So, lovely, fantastic, and wonderful. All right, I'm going to go blue marker this time, okay? Next one. Whew, it's a lot of factoring, man. It's tiring. It's tiring. Hopefully you're sticking with me here. I appreciate it if you are, okay? So here I can't divide everything by the same number, so I'll just go straight up to the grouping portion here. Boom. Lovely, right? We got GCF of 4x squared this time. Cool. And I'm left with x minus 2. And then we got plus 7. And we got x minus 2. All that equals 0. Awesome. All right, next bit. GCF here and here. That comes out. I get x minus 2, leaving me with 4x squared plus 7 equals 0. So that 4x squared plus 7 cannot be factored, right? So I'm at the point like this one here where I'm just going to set this stuff equal to 0. We get x minus 2 equals 0, so x equals 2. Easy. All right, this one here is going to be a little bit more complicated, which is exciting, right? Let's subtract 7. I get 4x squared equals negative 7. Let's divide by 4. I get x squared equals negative 7 over 4. Now, I'm going to go ahead and square root on both sides, okay? This is where the fun begins. I'm going to pop over here and work this way, okay? So we're going to have x equals, we've got plus or minus, right? I have a negative in there, so I'm going to pull an I out, and I'm going to write this with a square root in the numerator, which is 7, and a square root in the denominator, which is 4. Because now we can see, oh, I just had the square root of 4, right? You can individually square root each one of these. That is legal, okay? You can write it over the whole fraction, but because I'm looking ahead, I'm seeing, okay, that's going to be a 2. So then we're going to have plus or minus I, and then it's root 7 over 2. Whoop, 2. All right, last one, dogs. First thing I'm going to do is I'm going to check to see if we have a GCF between all 4 of those terms. I do not, so I'm just going to group the first 2, the last 2. Always keep that sign of the first term of the second group there. Keep that sign in there because we are going to take that negative out with it every single time. All right, so GCF in the first 2. I can divide that by 4 and by x squared. So we can take a 4x squared out, leaving me with 2x plus 3. And then here I can just take out a negative 1 from each one of those. So minus 1, and then we got 2x plus 3. All that equals 0. So there we go. We got the GCF, right, the common factor there between each of those terms. So I'm going to take out the 2x plus 3, and then I'm left with 4x squared minus 1 equals 0. Woo! We haven't seen one of these in a while, man. We got a difference of 2 squares. I can break that down further. So we got 2x plus 3 times 2x minus 1 and 2x plus 1 equals 0. So difference of 2 squares is very common to come up when we're doing factor by grouping. So always look for the difference of 2 squares to see if you can break it down further, especially if they're just asking you to factor it. If we were just asked to factor, that's our answer. Because we're asked to solve, I got to set each factor equal to 0. So 2x plus 3 equals 0, 2x minus 1 equals 0, and 2x plus 1 equals 0. So over here, I'm going to have, let's see here, 2x equals negative 3, so x equals negative 3 over 2. There's one solution. Then we got 2x equals 1, so x equals 1/2. It's another solution. And then 2x equals negative 1, so x is going to equal negative 1/2. Woo! And if I were to set the 4x squared minus 1 equal to 0, use square roots to solve, I would have gotten plus or minus the square root of 1/4, which is plus or minus 1/2. So there we go. We get the same solutions regardless of how we did it. You could have set this equal to 0 afterwards. I think that's fine. But because we said by factoring, I just wanted to factor until I could not factor no mo. All right, that's it for the factor by grouping here. That was dope. That was awesome. You guys are awesome. Have a wonderful day.